the introduction. Since you already introduced me, I'll just go briefly over me. I'm Emma. I started with squads about 10 years ago. Um, and I shipped my first piece of software about 30 years ago. So I did have to make a few times this decision of what technology tech stack to choose. Which is what we're going to be talking about today, especially in the context of startups and new projects. So first, we have to take a look at why this matters. Um, First of all, there's a few startups that have failed because they chose the wrong tech stack. That happens. And but oftentimes it's not because the stack that they chose was not technically adapted to their needs. It was more about everything that's around that. Um, Things like availability of talents and costs of running their operation and a few other things. So here we're going to be talking about a framework to make decisions on how to choose your tech stack. And this is something very valuable because when you have a framework, you make a more rational decision based on this framework and based on documented decision instead of going more with gut feelings or biased or emotional decisions. Um, so as I was saying, the impact of a tech stack can be seen on multiple level. One of the most important ones is hiring, and depending on what technology stack you choose, this means that there will be more or less people available that can get hired and contribute to your project in the mid to long run, or even on day one if you're starting brand new. There's also concerns of development velocity. Some choices allow for faster development, others slower development with usually other advantages. And finally, there is the maintenance cost. The long-term operation of your project. Is it going to need 5 people, 10 people? Are you paying licenses? Do you need 10 servers to run your project? Things like that. When trying to pick a stack, often there are pitfalls that can be avoided. One of the most common pitfall is that people want to go with the latest trend and what is cool right now. And what should we do? Should we go with GraphQL or should we go with microservices? Should we go with all that kind of things? And more often than not, it's smarter to go with less trendy technology and go with something that is more entrenched and that has proven itself and has more people that can work on it. Another pitfall is over-engineering and trying to think of problems that you don't have yet, like scaling for Google size companies, while most startup will never reach that point. Um, and also understanding the maintenance costs that I talked about. Um, Things that you should not be worried about when starting a project is to look modern or try to imagine scales that are way too large for your current problem. Um, so what matters is maybe you do have niche technical requirements, or performance requirements, or you already have a team or external, there are also external factors that can weigh into the decision. So let's dive into each factor and starting with the technical requirement. This one is often one of the most complicated ones because sometimes it's not easy to distinguish between a technical and a business requirement. There's also economic factor and performance versus productivity trade-offs. So let's take a look at these two examples: real-time collaborative document editing and sub-millisecond latency. Those two requirements can, at first glance, look like they're both technical requirements, but the first one is not really so much technical. There's already a lot of tools that do that. You can think about Google Doc, Jira, things like that, and also libraries. If you don't want to integrate an existing product into your solution, there are libraries that can help you do that. Something like sub-millisecond latency is something that cannot just be achieved with a library. It has to be engineered, it has to be thought through, and that would be an actual technical constraint that has to be taken into account while deciding for a stack. Things that are somewhat niche and you should be looking for is speed latency. For example, if you're doing trading or if your project involves real-time communication, there is hardware constraints, like maybe your product has to run on mobile phones only, or it has to be an IoT device, or it has to be worn around the neck of somebody. There's offline capabilities. If your target audience is in a region that is not well covered by a cellular network, for example. Regulatory compliance, like GDPR and other standards or regulations that you have to conform to. And finally, something that often gets overlooked at first is the ability to integrate with existing software. So if you're going to be working and selling your product to companies that may have 30-year-old mainframes running in the basement, you need to be able to integrate with that. So here we can look at a specialized need, a niche need. Let's assume that this is a small startup that is specializing in devices that can detect that when elderly people fall, and this is something that they are wearing around their neck. They have noticed that most of the competition right now uses smart device that connect to their cell phone. And if a fall is detected, then the cell phone can trigger a call. The problem with the solution of the competition is that often elderly people are not they don't go around with their phone, and the phone is out of range. So when they fall, the call cannot go through. So in this case here, their niche requirement is to have a small device that is able to make calls independently of a cellular phone. And this is something that they need to integrate and put resource and money into. But they also have other needs like billing and customer management and stock management and that kind of thing. And for all those other things, they don't need anything specific. They can go with something standard, and they don't need to create anything from scratch or invest too much engineering time in that. They can simply use something that exists. Something else that I mentioned is performance consideration. Performance is often given too much space in a decision. Um, things like everything that's listed on the screen, most of these can be faked. Because what really matters is not the actual performance of a tool, it's the performance perceived by the user. So there's been, for example, studies that have shown that um, in interaction with an application, if there is an animation when you click on a button, whatever happens in the background can take up to 1 second, and the user will still feel that this is fast. While if nothing happens when they click on a button for 300 milliseconds, they will think it's slow. Even if it's 300 milliseconds, is 3 times faster than a second, the perceived performance will be bad. Um, and a nicely designed UX with this consideration can overcome slowness on the backend service. For everything web, CDNs can also be used to improve performance. Your application is not going to be faster, but things are going to happen faster for the user. Same goes with caching and that kind of thing. Then we have scalability, which is something that's often talked about us also when starting project. And here we have to look at the fact that most startups will not grow to be Google or Facebook or I guess I should say Meta or X or anything like that. So oftentimes looking at scale at those sizes is a waste of time in the first days. Um, and it can be a premature optimization that will cost you money, and that will, in the end, that might prevent you to reaching those size that you have been planning for. Because instead of planning for size, um, planning for feature will bring in more user, and if you have more users, you will earn money, and once you earn money, you can hire more people to then look at the scaling issue. Um, when you get to that point, it's also good to scale incrementally and look at the bottlenecks first. The first bottleneck that you are going to encounter most likely is database. And there's a lot of solution for database, starting with having a pool of database server with read replicas, database sharding, and that kind of thing. And in 90% of the case, this is going to be the first bottleneck. And by using good servers and good solutions, this is something that you're not going to be experiencing until you have at least 10,000 concurrent users. So even if planning for scale, for too large a scale at the beginning is not important, it is good to have an idea of where your bottlenecks are going to be, so that when you reach those bottlenecks, you can identify them easily and you have already a plan to move on. So I've been talking about adding multiple servers for your database, and some people are going to say, yeah, but that is wasteful to have many servers while you could be optimizing it and only have one server. But the truth is that hardware is cheap, humans are not. So usually the cost between a human and a computer is 10 times or 100 times more likely different. And same goes for CO2 consumption, which has become really important, especially in Europe. The cost of a human over a year is about 15 tons of CO2. And this includes office, eating, commuting, personal equipment, and all that kind of thing. So even though this is an important consideration, trying to optimize too early, too much is actually detrimental to your end goal. And it's easier to scale the number of computers than scaling the number of humans, and it's also less expensive. So here's a fictional example of a company that's whose business is to sell videos on the internet. And transcoding a video takes 2 hours once you upload it. And instead of optimizing that to maybe bring it down to 20 minutes, they decided to go with a cloud service and auto scaling, and they are using 6 times as much hardware, 20 minutes compared to 2 hours. They're using 6 times as more hardware, but on the other hand, they are able to not spend a lot of time on things like optimization and develop their product faster and get to market faster and start earning money faster. Time to market is a lot of the time the most important things that you're looking at when starting a new project or a new startup. So, since we're talking about humans, let's talk about teams. Um, because your team is probably what is going to be the most important thing in deciding what stack you're going to use. If you already have a team, using a technology or a stack that your developers are familiar with is going to increase the productivity probably 10 times. And if they have to learn something, they will not be proficient in that new technology for 3, 6 months, maybe a year. And during that time, they're going to be really slow compared to what they are able to do. So sometimes it's a good idea to introduce a new technology if there is a clear gain. Let's say that you found a framework that is really adapted to your specific needs, and by using that framework, you estimated that your team is going to be 3 times more productive. So this is a balance. Do you spend the time and money for your team to learn the new software to be more productive in 6 months, or do you want to look at that time to market and decide to go with the older technology that your team is familiar with and that they will be more proficient in? This is a decision to make. Of course, sometimes it's your team that is familiar with the technology but would like to try something new and shiny. And there are trade-offs between technologies and keeping your team happy and being able to ship project. There is once again a balance between innovation and delivery and predictability of your software. So if you have to use lesser known technology, there are mitigation strategies. One of the most important one, according to me, is pair programming. On paper, it doesn't make any sense. You're paying twice as much to get the same feature. In reality, it's probably more like 1.5 times because 2 pairs of eyes are going to be able to overcome roadblocks faster. And there is also a certain amount of investment that is not accounted for here, is that you're going to be spreading knowledge, and your team is going to be able to collaborate better, and this is really going to pay off in the midterm. So when we talk about team, if you already have a team, that's good. But if you don't have a team, you have to hire a team. And even sometimes if you already have a team, you might need to grow that team. So something that's quite important to look at when deciding for tech stack is how easily is it going to be to recruit new developers. If you look at these numbers, you will see that there is one order of magnitude difference between the number of JavaScript developers and the number of Rust developers. So it's going to be much easier to recruit somebody to do JavaScript than it is going to be to do Rust. Also, it's probably going to be less expensive as well. Another key point that may come in to mitigate that decision is that last column that's called verbosity. This here represents, according to official readmes, the number of lines of code that you have to write to print hello on the screen. And so if we look at what I'm going to call the worst case scenario, which is C++, where you're going to need 6 lines to write that, if that verbosity scales, and this is a simplistic way to look at it, but for this example, let's take those number like that. And so to write a feature that is going to take you 6 C++ developers, so that's almost a third of a million, when you could have achieved the same thing with one Python developer for 50K. So this is something that has to be weighted in if you're looking at new technologies. The best case scenario is low verbosity and high availability of people, with the worst case scenario being high verbosity and a low number of people. Um, So there are downsides, upsides, and downsides on both kind of choices. So if you want to go with something trendy like Rust, it is likely that you're going to be attracting mostly people that are more passionate about what they are doing and that have a higher level. While if you go with something stable and boring, you might end up with people who are bored and don't really have a passion for their work, but they will be easier to replace. In any case, you have to remember that hiring people has a training cost, and so availability is important, but turnover is also important. So if your team is bored, you're probably going to have a higher turnover and will be spending more money on training new people. So here we have a case study between two fictional companies, and there's in both tracks there's a lot of possibilities for failures. Um, the key points are that by hiring known and technologies and with high talent pools, the first company is able to hire 8 developers in 3 months, and that would cost them about 300K. And so they would be able to produce an MVP much faster, maybe 4 months. The second company is going for very niche technologies, and so they are able to hire less people in more time, which results in only being to produce an MVP after maybe a year, and for a bigger hiring cost. When looking at that first table, it might be obvious that the first company is the winner here. But if you look a bit further down the line, maybe the edge tech solution was sold by a very specialized bank, and they sold at 3 times the price of Fast Track, and the first company, or it is going to take them a little bit of time to get started, but once they're
Genuinely.
started, Hello? Okay. Once they are started, they will probably be able to turn out new features much faster, but they will have to get over that initial hump. So I've been talking about humans a lot, but we are in 2025, so we also have to talk about AI and how that comes into choice of tech. Um, Whether you want it or not, AI is going to be present in our line of work, and AI is a great tool. It is really good at code generation, especially boilerplate and repetitive code. It's good at pattern recognition and at knowledge synthesis. It is not that good at strategic thinking or thinking, real thinking at all. It is pretty blind to tech depth, and it has no higher level vision. Um, so you are probably going to have it integrated in your stack one way or another, whether it's a developer using Copilot in their editor, or it's somebody who is going to be vibe coding, is going to be present. Um, like any other tool, it has its upside and downside. It's really fast at churning out code, new code. But in the long run, anything that is created by AI is probably going to be harder to maintain. Um, so, for example, code generated by AI is usually not reusable. It has issues with long-term scalability and maintenance. And AI also usually struggles with higher level thinking and things like architecture, um, or coming up with new ways of doing things. So the AI is only regurgitating what it has learned. So it's going to be able to easily copy something that it has seen before, but it will not be able to come up with novel ways of doing things. So for decision making, like choosing a stack, AI is probably not the best tool to do that. Even if it's going to be included in the stack itself, it's probably going to make the wrong choice for the wrong decisions. Once again, it is trained on data available on the internet, and people tend to write articles on problems they have and things they encounter, or the new shiny software that is trendy. But people don't write article about how I've been doing boring code in Python, and it's been working fine and I had no problem. This is not an interesting article. So there is less content about that, which leads to AI having less visibility of those when making decision. Um, AI is probably also going to be really bad at risk assessment, and it's usually going to be lacking a lot of context, except if you type it in. But this brings us to a topic like vibe coding. Um, I don't know if you're all familiar with vibe coding, but basically this is logging into an AI agent and telling it, hey, I want to build code with this feature and that feature, and just then be hands off and wait for the AI to generate code, test its own code, and finally output something that usually works. Um, so vibe coding is great, can be a great tool for startups, and you will probably see on YouTube bunch of videos that pop up with founders that have vibe coded their own product and sent it to market directly. Um, Vibe coding is allowing people to produce a lot of code really fast. Um, so it is great for writing proof of concepts, learning a new tech, doing tedious tasks like writing tests and that kind of things. But it is less good for a production system, critical piece of code, um, and maintainability. And as I said, it's also really bad at code innovation. It's going to regurgitate what it has seen and not come up with new ideas. But if you use vibe coding in your stack and you get a product from vibe coding to production, there's some really necessary step. This is not optional; it's completely mandatory. Where you will have to assess the code that has been produced, identify the good features and the good patterns. Plan and redesign a proper architecture, which is probably the most complicated step because when you're starting something from scratch, it's easy to say, oh, I'm going to do this way because it's a good idea, because then it's going to make for a stronger build or something like that. But looking at something that someone else has built, it's harder to identify pieces and say, oh, this is the part that makes the software brittle, or this thing is not good because it's not going to be maintainable and things like that. So it's harder to do, but it still has to be done. And once you have identified all that, you have to rebuild and test. Um, AI and vibe coding, as I said, is a tool. And if you can wield it right, it is a great tool. But if you cannot wield it, it's going to be disastrous. Think of you buying a really expensive screwdriver to build a cabinet in your office. If you can have the nicest screwdriver in your hand, if you're trying to screw the screw in the wrong way around, it's not going to go in. AI is like a screwdriver, so it is best wielded by senior developers who will be best able to guide it and produce something good to start with. So, next point, we're moving into strategic planning and decision making. So we've been talking about scalability and how this is usually not something that you have to worry about when starting a new project. And here is a list of what are the things that you're most likely going to have to worry about given in a certain time frame. So the first few months, you're just going to, after really the initial release, you're just going to be mostly fixing bugs. And that is going to be easy. Then 6 to 18 months, you are going to have to deal with library upgrades and framework upgrades because, well, you've been using tools. Nowadays, nobody builds everything from scratch anymore, so you are likely to have been using things that are going to need to receive minor updates. So this is what you're going to have to deal with. Um, and after the 18 months, maybe you will have to do major changes because one of the libraries that you had been relying on is not maintained anymore or that kind of things. And it's only starting at 3 years that you should have to start looking into changes to your stack. And you probably want to do that gradually, not change everything at once, but change part of it piece by piece. So when you're thinking about your original stack, you have to think about how it can be modularized and how pieces of it can easily or not so easily be replaced. Whether it's when you decide on your new stack or when you're changing your stack, a way to make good decision is to have a decision matrix and have every possible choices, staying with the old, going with the new, and have weight on how important it is to for some goals. So, for example, developer familiarity is probably the most important thing. Um, and once you have everything written down, it's easier to make a decision. Making a decision also has to be beneficial for everybody. So one way to see the success of one decision or another is that every part of the business need to be able to express in their own words that this decision was a good thing for them. So, for example, for the business leader, it will be quicker time to market, while for the product team, it's going to be feature velocity, and for operation, it's going to be reliability, for example. Um, to talk about this time a real life example, Instagram started with Django and PostgreSQL as their initial technology choice. And when they started hitting more than 100 million users, this is when they started to see the limitations of their stack, and that they needed to start replacing piece of it. They never did a big rewrite of everything. They always started replacing things one by one. And so they added a new database. And then they started writing microservices to process images. And they improved their caching system. And if you've been using Instagram, you probably never even noticed that they changed anything in the background. So the four things to ask when deciding on a tech stack is: do we have a niche technical requirement? And most of the time for startups, the answer will be no. If we have a team, what is our team familiar with? Or if we don't have a team, what is the technologies that are going to be best to hire with? Um, then the business, what is the timeline, the budget, and the future? It does come in, scalability comes into action, but only as a plan and not as a feature at the beginning of the implementation. You can use the sheet that I showed before to for all of these points and all of the technologies that you're planning, score everything, weight everything, and this will give you a final score for every technology. No one's trying to find a new technology. We've been looking at internal factors, things that you have mostly control on, but there are external factors as well. Um, Probably the more prominent one is vendor locking and licensing. Nowadays, a lot of cloud providers try to lock you into their solutions, whether it's a queue processing solution or it's their own way of doing serverless or something like that. Um, so this is if you make the wrong decision and get locked into a vendor, they can increase their prices as much as they want, and it will be really hard for you to leave. Same thing with licensing. I mentioned that it's easier to integrate than to develop things in-house. But when integrating with a third-party service, you have to pay their license. And at some point, it may be useful to have an option to move on to another provider or to have your own team develop something. There's also open versus proprietary. Oftentimes, proprietary solutions will have better support, flexibility, and things like that. While open source, unless they're backed by a company, um, is going to be highs and lows, where you need to check the health of the community and whether there is resources, documentation, that kind of thing, if all that things is available. So documentation, if you're using a niche library with almost no documentation, this means that your team is going to be spending a lot of time trying to figure things out. Community activity is quite important as well. Things like forums and whether there's releases, bug fix security releases, that kind of things. A good sign of whether an open source an open source solution is viable is, do they have a third-party ecosystem? Um, and to have the best of both worlds, if they have a corporate backing, this means that you can pay for the service and have the tranquility of mind that this solution is probably going to stay around as long as the company stays around. Um, Technology maturity is important as well as compliance. Uh, Emerging technology is probably going to go through a lot of changes. So if you're using an emerging technology for your solution, this means that you're probably going to have to often adapt to breaking changes and change your own code or stay on older versions that might not have all the features that you need. While a mature technology is going to have been already production ready for years, and they will also probably have been reviewed already for compliance requirements, things like SOX or GDPR or things like that, and they will certainly make your life easier. Um, they will also probably be easier to upgrade. So when choosing a stack, this is something that you have to look at. How easy or how hard is it going to be for me to move to the next version when the time comes to upgrade? Do they have tools? Are they introducing breaking change every release? Are they changing paradigms all the time? Things like that. Also integration and compatibility. Does this work with my single sign-on application? Can I do monitoring? Can I use APIs to connect to other systems? And finally, this means that you're going to have to do a cost analysis. Um, and especially take into account the hidden cost, like the upgrades and migration cost, but also the before cost, so the initial, the training, the setup, all that. The during, so development cost, and the after, how much money is it going to cost me to have to be able to scale? We're running a little bit low on time, so I'm going to skip this next section, which is not less important, but is probably more obvious, which is the operational and quality considerations. And I'm going to move on to the summary and the takeaways. So during this webinar, we have seen four factors to take into consideration or making this decision. These are technical requirements, the capabilities of your team or your future team, the recruitment realities, and the external factors. You can take all those, put them on paper, and start working technologies like we've seen in the matrix that I showed before. There are four principles also that are easy to keep it in mind. Hardware is cheap, people are expensive. AI accelerates but doesn't strategize. And team capabilities are more important than technical perfections. Choose what your team can do, not what would be the perfect solution. And finally, technology stack are living systems. So make a good decision to start with, but also try to make decisions that you can change later on. I think we still have a little bit of time for questions. So if somebody has questions, I'm here and listening. So yes, I will upload the deck after the session is over. Shrikant, you're muted.
Hi, everyone. I think this was a fabulous webinar, and I was underestimating the intensity of the topic actually, but I learned huge amount of things actually which I never thought about. So I was just wondering if people have any questions, they can really. It's a good time to ask those questions here.
Shrikant Sunil here.
Yeah. Hi, Sunil.
So, am I audible?
Yeah, you are audible.
Yes.
Yes.
So, I have questions around the external factors. So, just I glance around 2 3 points wherein Emmanuel has mentioned it. So, my questions around the external factor is that does it impact the political instability across country?
Yes, absolutely. Right now, there's quite a few companies that are looking at taking their services out of the US. Mostly not so much because of the new tariffs, because those are mostly on goods and not services, but because people are starting to get more worried about data integrity and how easily the US government can get access to their data, for example. So that absolutely takes comes into play, and depending on where you live, you might want to avoid certain countries for political reasons, and that also joins purely technical reasons. If you are able to, if you're doing like most startups, if you're doing something that's based on the internet, you probably want to deploy your new service on something that is close to your customers. So if you're in Europe, you're going to want to do that to be able to deploy it in Europe. And if you're in India, you want to be able to deploy it in Southeast Asia or India or anywhere close to you.
Thank you so much. Thanks. I'm done,
You're
Shrikant. Thanks.
welcome.
Any other questions from anybody? Okay, so if there is no further question, then that's it for this webinar. Thank you so much, Emma, and the audience to join this webinar. It was a great session, so I'll be making sure that it is, I mean, published as well. So I'll be sharing you the link or your email, and also we'll be sharing the deck.
Thank you. Thanks.
Thank you. Thank you so much. Have a nice day.
Thank you. Goodbye.
Bye-bye.
Thank you so much.